Who could have foreseen how this ambitious research mission would get around and survive on the lunar surface? The Japanese space mission, a marvel of modern engineering, is now resuming its crucial objectives and coming back to life. A cold, twilight night can't lessen the phenomenal capacities of the Japanese Marvel vehicle,
Delta rocket carrying
Finn,
GLAST,
which is currently conveying information in manners previously unheard of.
Slim,
who is officially known as the Smart Lander for investigating the moon, set out on a unique mission that has the potential to change how we think about the moon. In January 2024, this state-of-the-art Japanese space test accomplished a huge achievement by effectively arriving on the moon's surface. This achievement denoted a notable second, as it was whenever a lunar test first had arrived inside only 50 meters of its designated site. The precision and expertise of the Japan Aerospace Exploration Agency, or JAXA, can be seen in this remarkable achievement. Not only was it a technical success to land so close to the designated location, but it also serves as a reminder of Japan's advanced technological capabilities, yet again known around the world for their advancement in innovation and liveliness. The Japanese have exhibited their ability in space investigation. Their previous achievements remember handling a test for a space rock, which included conveying a meanderer and a psychic vehicle for nitty-gritty logical investigations. These spearheading advancements have permitted Japan to concentrate on space rocks and comets, giving basic bits of knowledge that might actually defend humankind from the antagonistic impacts of these heavenly bodies from here on out. Japan's most recent mission to the moon demonstrates the nation's ongoing dedication to space exploration. In spite of the normal discernment that the moon is a successive objective for space missions, arriving on its surface is full of difficulties. Russia, for instance, has battled with missed landing locales for its lunar tests. India's Vikram lander and rover both suffered setbacks, and only China's rovers have consistently performed well. Slim's design, which was specifically designed to land close to the lunar equator, demonstrated Japan's technological ingenuity. Notwithstanding, the mission confronted unanticipated difficulties. During the last arrival stage, Finn experienced a motor issue that made it lose height and speed, bringing about the test arrival on its side. The mission was significantly affected by this side landing. The efficiency of Slim's solar panels was impacted by its tilted position. The probe's inability to successfully charge its batteries was impacted by the fact that it received less sunlight because it was not standing upright. Additionally, Slim's ability to send and receive signals was made even more difficult by the angle of the landing, which altered the alignment of the communication antenna. The mission encountered significant obstacles as a result of these technical issues. Japanese engineers showed remarkable resilience and creativity in the face of these challenges. They reclassified the test's activities to adjust to the difficult circumstances, guaranteeing that Finn could proceed with its main goal. The effective administration of these obstructions, including defeating the issues connected with the test's direction, permitted Finn to continue its logical exercises after a time of hibernation. The fact that Slim continues to function is evidence of the efficiency of Japanese engineering. The test has figured out how to do its logical obligations in spite of its restricted energy assets and not-so-great landing area. Slim finds it challenging to maintain a constant connection with mission control due to the additional communication obstacles presented by the moon's horizon. The test can send and get information discontinuously, which represents a critical test for progressing research. In 2023, India confronted issues with its Vikram lander and Wanderer, basically because of deficient warming frameworks during the unforgiving lunar evenings. Slim, on the other hand, was successful in overcoming similar obstacles. High-resolution images of the moon's surface were taken by the probe, demonstrating its innovative sleep mode strategy's capacity to withstand extreme temperatures. To conserve energy and maintain an internal temperature above -4 degrees Celsius, almost all systems were turned off in the sleep mode. Experts, including those from NASA and other space agencies, initially viewed this strategy as risky. However, Japan's risky strategy paid off, proving to be a successful solution to the issue of preserving operational stability in the icy lunar environment. On February 25, 2024, Finn stirred from its rest mode and conveyed a message back to the JAXA group, denoting a critical accomplishment in space innovation. The fervor and celebration among Japanese researchers and the worldwide space local area were discernible. Thin's capacity to impart in the wake of enduring the brutal lunar night is a vital achievement, highlighting Japan's driving job in propelling space investigation. This achievement improves Japan's situation in the worldwide lunar investigation scene. Japan's contributions, which include vital life support systems, will be beneficial to NASA's upcoming Artemis project, which aims to establish a sustainable presence on the moon. Japan is also working on new lunar probes that will build on SLIM's research and help us learn more about the moon. The rolling ball-shaped design of one of these new probes allows it to independently navigate the moon's surface. This creative meanderer can open up, expand its legs, perform bores, and gather tests. Its capacity to perform definite overviews and accumulate information from different areas on the moon will altogether improve lunar investigation endeavors. The rover's design makes it useful for future missions because it can adapt to different terrains and complete tasks quickly. The focus now shifts to continuing scientific experiments and data collection, particularly in the Shoemaker Crater region, now that SLIM is back in action. Moon exploration is increasingly becoming a multilateral, collaborative endeavor. In order to improve our space capabilities and knowledge, international cooperation is essential. A global community that benefits from these advancements in space exploration is actively fostered by the United Nations. Russia, the European Space Agency (ESA), Japan, India, and China are among the nations collaborating to promote peaceful space cooperation and mutual benefits. This cooperation is fundamental for accomplishing long-haul objectives in lunar investigation and laying out a supportable presence on the moon. China's Chang'e mission has made huge disclosures, including little glass globules containing water on the moon. For future lunar colonization, this finding has significant implications. The presence of these water-containing globules recommends that future lunar pioneers will actually want to concentrate and utilize water straightforwardly from the moon's surface, wiping out the requirement for broad penetrating or shipping water from the lunar posts. Every one of these missions adds to the more extensive objective of fostering the moon as a tenable and monetarily practical space. The trading of advances and information between space organizations overall is driving advancement and development in lunar investigation. Insights into the moon's geology from SLIM's work at Shoemaker Crater are crucial for future habitation and economic growth. A type of helium that could power future fusion reactors has also been found on the moon by Chinese astronauts. Atomic combination, which is a possible answer for the world's energy issues, could be saddled utilizing helium tracked down on the moon. This headway could prompt the advancement of lunar-based power plants, giving spotless and reasonable energy and supporting different exercises on the moon, including space transport dispatches and agribusiness. The fantasy about laying out a super-durable human presence on the moon is turning out to be progressively practical. This endeavor will rely heavily on the exploration of lunar resources and their utilization. Click the buy in button now to remain refreshed with energizing recordings about space investigation and the most recent improvements in cosmology.